almost all of us have tested when we're young, running at night in paths that we are familiar with, and really enjoying our memory of that path. So we can get, if we're familiar with the territory, we can guard a quite large territory just tactilely, because we can run around it and find out what's happening at various places. I have then a limit range when I'm standing still of, let's say, 10 feet and giving this maximum possible, and I can get also information as fast as I can run around. So I could add the speed of running to it. So let's say that I can run, and the difference of the Paine is important, and in approximately still weather, he has been able to get it up to 5 miles. If the wind is blowing, it could blow the smells of the forest fire or pines or orange groves great distances. The smell could come as fast as the winds blow, and we have records of winds blowing well over 200 miles an hour. If the jet stream actually sweeps down and touches them, we might get starting off with 10 feet. And 10 feet is in relation to, say, 5,000 feet in a mile, 5,000 to 180. Let's call it 1/50th of a mile. I start off with, I'm going to have two things. On this side here, I'm going to put the distances, the original seeing or the original reaching, and then I'm going to have another curve here out this way, which will be the velocities. So I have something around a 50th of a mile for my touching, my reach, and I can get up to running 10 miles an hour, so I come out to start at as much as I get up to 900 miles an hour, 1,000 miles an hour for the sound. I'm going to call this up here 1,000 miles an hour. So this would be 500 miles an hour, and this would be 200 miles an hour, and this is 100 miles an hour, and here we are, 10 miles an hour. Right here, very close to that. I'm going to have a point here, and I'm going to have a point here. I'm going to multiply these times so that they're one. Now, that is for my touch. My hearing takes me up to 500 miles an hour and 5 miles. What am I going to have for altitude here? I might make this 100 miles here. This is the greatest hearing. The second one, which is the olfactory, it will certainly smell the breast. It tends to find tactilely and olfactorily the milk. It doesn't hear for several days. Hearing comes in next. It is quite a few days later that it begins to see. It's interesting that the new life employs these faculties in the order of the magnitude of their capability. It starts in, however, with tactile. That is this first one is tactile. That's the basic sense, apparently. It's an insectine sense. We see the insect doing this. Now, pretty soon, however, it begins to coordinate olfactorily. It sticks its finger in its mouth, its hand in here, and when making noises, it's correlating tactile and olfactoral, touching it, and then it begins to make sound. It begins to cluck about a week later, and begins to correlate the sound as well. So it's making the noises with its mouth, and it is feeling. The fact is, you do not. But the velocity at which you're seeing is so beyond your apprehending in the terms of your first three coordinating informations that you call it instantaneous. The fact is that the light bouncing off my hand gets into my eye in approximately a billionth of a second. Comes through the lens and gets telegraphed back into the brain. And here is where we reconstruct all the information we get. No man has ever seen outside himself. We know this is so. We know he sees in the brain. He has a television set in it. And in this television set, he is recording. Now, we tend to think of a television set in a frame, a little box. But it'd be quite possible, we know we've got larger and larger screens, it'd be quite possible to make a so large a screen that you could really, in effect, be inside the television too. And if you're inside the television too, interesting. When you're out, when it's in a little frame, you look at it as a picture, but then there's another reality out here that you reserve yourself. You know where you are. But if you're inside, if I insisted to put television screens everywhere, every window you look at, because I saw how easy it is to fool ourselves, because somebody will put on they put on a makeup, or just the children come around with a Halloween mask, and you have to admit that a very innocent, handsome little child looks very, very strange and has a strange effect on you. Even though you know it's a child, you know it's a mask, nonetheless you have a sense of grotesqueness. It was a very little child, very pretty little fawn-haired girl who came to our house the other night, but she had a mask on, and it was a tough old man with a cigarette hanging out of her. And this character went around, and you couldn't get over the feeling. It was really quite a debauched little character was walking around your house. Our tactile senses are very powerful with us, even though we know much better. Now then, major new information they've never had before, and they don't know what to do about it. They freeze. And you can see that happen with much of life, and which will even develop a protective coloring so that it can do this freezing, so it will not be detected by phenomena they don't know how to deal with. She says man must have done the same thing. And she has good anthropologists give her many, even good living demonstrations of that being so. That people freeze in their tracks, or they try to stay concealed, and they try to be invisible first. If they find that, she says, however, life goes out, and then it goes from the static, invisible posture. I want of them in order to be able to get to happen. So you would imitate very, very much this food. If you were talking to people about food, and you are not a hunting people, you are an agrarian people, the things that grow in the field, their bottoms are rooted. So you would talk as wheat. You would talk as trees and so forth. You would talk to the top part of you instead of the bottom part of you. She finds that the dance tends to break into two main categories, really the bottom dancing people and the top dancing people. There's some who dance with both. But I found it fascinating in South Africa to all the South African university students speak English and Afrikaans, which is the old Flemish, and almost all of them speak one or two of the native languages of South Africa. They speak Swazi or Zulu, and the Swazi and the Zulu and so forth, the students refer to all those languages in this business of the top talkings and the bottom talkings, and some good speculation as to the order of events, the way very complex things develop. But she points out that because she is a dancer, that she realizes how much you can communicate, certainly to other dancers. You begin to develop a language. And she felt then that the early dancers, or you were running out, you're getting bad balances of males and females. There were urges to balance with nature. That the people then learned that these, by doing these things, let's take a chance. This is a big bet. We all get up to the ridge of the hill and start doing this thing, and sure enough, these people catch on, and they suddenly lead us to where there's some food. And therefore, you try to get safe. So you begin to identify this phenomenon, which is not as yet called a dance. Communication is identified with his survival and his successful survival. Therefore, you set an enormous store by it. And so you begin to teach all the young people in the family group here how to do it. So you have all kinds of lessons. They're brought up to say this. Gradually, however, this new device of sending the drawn picture communication away began to obsolete this kind of communication. But the people who are being taught it don't know that. They can twist things. They also contract. There is contraction, shrinking. The opposite of which is expansion. Expansion and contraction are the same. We might call those association. We come together or we separate out. There's different ways of saying this, but the pattern gets larger or smaller. It's a change in total diameter, not just an axial stretch. Then we have another one which would be inside outing. Stick your tongue out. I'm starting to speak to my inside mouth. You can't get it out very far, but we do turn things inside out like a glove, a rubber glove. And there are people in South America who can turn this completely inside out. But in concavity are involved, rights and lefts are not interchangeable. And in fact, convex and concavity is always operative. There are no systems that are innocent of convexity and concavity. Therefore, rights and lefts really are not the same. At any rate, two young men at Princeton, two Oriental boys at Princeton University, Institute of Advanced Study, received a Nobel Prize 5 years ago for discovering the fallacy of parity. They found it out in the terms of the atomic behaviors, because they found that these atomic behaviors, some of them, they turn right, some turn left, they cannot alternate, they cannot reverse them. They're irreversible. These are irreversibilities. Physical irreversibilities proved that parity was palatial. This has just been found out by the scientists. Therefore, we'd be warned that it's very easy to get confused by the words right and left and concepts of parity. Now, there is, sit down on there. Automatically, as you touch that ball, each ball, it's going to have to change the angle. So the ball is coming along like this, and you hit it, you touch it with your finger, and it's got to go down like that. Each ball, as it comes to you, your finger touches it, and it angles down like this. Very quick, so that the balls are coming around in this plane, and this next ball is going to go down here, so the next one's going down here. They establish a new plane. They're literally going to have to bend the wheel, and until the last ball gets to you, and now all of them are in this new plane. You put them into a new plane, so they keep on the angular momentum in that new plane, so the balls have come up here in that plane. So simply the plane got bent over like that. It's quite if it were is a hard wheel, everyone that goes by in the plane. But finally, they form a new plane, and the new plane is this action. Now, we come to something quite important. When you, I was on bearings on my head and feet, and we put the bearings themselves in gimbal rings, 90-degree rings, so that when you touch those balls going around me, it made the plane go like this. Therefore, it makes my body go like this, because I am 90-degree rigid to these. So that the result of your pushing down on that ball was that I tip over like this. I bend like that. I'm perfectly comfortable in the area. It got me nicely rigidified between these bearings. All right? The fact was, and the line of your motion was like that, and the resultant was that I went over here. This is what has been considered completely perverse in the gyroscope. That is, if you will I'll now take a rigid wheel, and its axis at 90 degrees to it here, and you take a pencil and touch that wheel, and the here is such that press down on this one, because it's in tension, you can see, and it's cellophane, I've got many layers in it, it won't yield, it won't stretch. Therefore, this forces, if I push down on this one, it forces this one to go up around the inertia of this one. consist of a great many atoms, and they are stacked quite deeply here. So in order to get that kind of a picture, I will get my hammer thrower loaded up. Not only do I have him give him the original set that just tangent to one another, but I give him twice as many more balls. And half of them will be on top and half of them on the bottom. And because he is moving so fast, and they want to go out at 90 degrees to him, be the greatest distance from him, the top balls and the bottom balls will press the center group of balls. That is, this ball will be pressing downward, this one's pressing downward, trying to get into this position, and this one's pressing upward. I have enough layers like that, and just the motion itself makes this cohere very tightly. And the coherence then will throw enough friction between this one and this one to use that cellophane layer, so that the tension is in the system all right. Therefore, when we press on any part of this system, like I'm pressing upon, pushing on this axle here, and it yields this way, it throws a terrific strain into that wheel through all those atoms, and it gives it quite a shock. You could break it, growing larger and larger from it. Something else, if you did a moving picture of it, you'll see that as it dropped in the water, as a result of 90 degrees to the impact of the Earth, and it starts outwardly like this. Not only does it start outwardly like this, but it is the outward motion like this begets a 90-degree motion. So the outward like this begets an in towards the center of Earth, and the in towards the center of Earth begets a more outward motion. So we find this generates a wave. That is why you have a wave. As a landing like this begets this, which begets this, which begets this, which begets this, and the wave simply is a continuity of disturbances of a plurality of molecules. The water doesn't move anyway; it just goes in and out. But a phenomenal wave going through here is a precessional effect. And then there's a counter precessional. I'm going to write the word energy here. I'll just put a hyphen in between these prefixes, sen and n. And the prefix syn we're very familiar with in synchronization. Synergy and energy are companion words and are equally old. The word synergy means behavior of whole systems unpredicted by the behavior of any of its components or any sub-assemblies of its components. The testing of audiences around the country regarding the word synergy and the finding that the word is not understood makes clear blue line. I could run it the other way. You see the two tetrahedron in the cube. Now I put it in white here. You see there's my other tetrahedron. Now, when the first tetrahedron was operative independent of the other tetrahedron, the coherence of the four stars of the tetrahedron, in the terms of Newton's gravitational relationship, that is, in the terms of the second power of the relative proximities of those stars, that's their coherence. When I bring 4 together with the other 4, now 8 of them are equidistant from the same point, the diagonal of the square away from the other star. Now the next nearest star to it is only the leg of the triangle. Here we have a right triangle and a hypotenuse and the leg. We have the second power relationships of legs and hypotenusae that are involved. The second powering relationship of gravity begins to be very clearly explained. And each star, instead of having just one other star that is attracting it, each star has always 3 stars around it, pulling on it. So it is pulled three ways, and so the second power proximity is a threefold effective affair. To discover, for instance, then, the chrome-nickel steel 300,000 is then it's 5 times as strong as its weakest link. If we spoke about iron as the weakest, is 60,000 to 300,000. And the array is a theoretical array. But the array is of experience which is finite. All the experiences themselves are finite. The experiences always begin and end. And because we are, as experiencers and communicators, we all sleep and wake and sleep. We operate in packages. We are discontinuous. Therefore, I saw that the experience, the sum total of all experiences, was a great discontinuity. And I began to say then that the universe is quite clearly finite because it is an aggregate of separate finites. And then I began to say, what of non-simultaneities. And yet all my important thinking is in the terms of non-simultaneities, because I group together a plurality of my experiences in pulling out generalizations of which I'm beginning to discover patterns which give me a concept of consequences. When I be able to make predict a consequence, then I am dealing in, that's the consequence of non-simultaneous. If I begin to be very proficient in dealing with non-simultaneity, and that's just what I thought does. There is a word called epistemology. Epistemology means the science of the thought processes. And what I'm doing right now is really, I'm engaging in epistemology. Because I'm now interested in how man thinks, because I now have it in evidence that he can't think about the whole universe at once. So I think he has often thought he could. I think he's often said, what is the shape of universe? He often says that, well, if there's a shape to it, it would have to be simultaneous. Concepts is many different kinds of lives. Therefore, the thoughts are not only non-simultaneously considerable, but then non-simultaneously recallable. I used to call your attention to the word consider. Consider, S-I-D-E-R, consider stars. Stars are here, so I want you to kind of think of an omnidirectional halo, an effulgence of lucidity. As simply how a spherical zone with a black or an unreadable interior and an unreadable exterior. And in that halo, I say something very interesting is happening. That halo with a spherical zonality is a geometry. It is a geo. It's interesting then that starting with an amorphous and non-simultaneous, non-shapeable universe, we discover that our thought processes themselves become the first shapeability. And the shapeability is a geometry. And if there's an understanding, it's because we now know all the stars in any of the circuits within the halo. Then we're able to go on to the next halo. And the next meeting is this, that if I talk a little faster, there are little items which I would like to bring in which will make what we're considering a little more interesting and lead on to a little more. And life isn't worthwhile unless it is a little more interesting. Therefore, I work awfully hard to bring some more in. So there is in this relevancy, and there is a zone of clear, there's a lucidity zone, but then on the inside of that zone, around the sphere of non-considerability, of the microcosmic group, there is, between the zone of lucidity and the opaque non-considerability, there is a zone, a twilight zone that'd have to be. And in that twilight zone, there is tantalizingly almost relevant. And if I talk fast enough, I can bring that one in too, make it less more interesting. So I discovered that a zone of lucidity must have two twilight zones. Must have a twilight zone adjacent to the macrocosmic irrelevancy. Now then, next I will give you is that I say, how is clear to me that a considerable thought is automatically then divides the universe into two parts, the macrocosm and microcosm. I say, how few events could provide a constellation that has an inherent withinness and an inherent withoutness? I find that it can't be done with less than 4 stars. 3 stars do not have a withinness and withoutness. I can't think then with less than 4, and 4 give me what we call the tetrahedron. Now my tetrahedron might be extraordinarily asymmetrical. It might be a tetrahedron with a very small base and a very great altitude. It might be such a small base and such a great altitude. It might look a little like a line. So something looks like a line, I know is really a tetrahedron of what I call elongated tetrahedron. Then look back at our tetrahedron again in a more symmetrical condition. There we see that 1, 2, 3 lines in the base, 1, 2, 3 lines sloping together in the teepee. There are always 6 edges to a tetrahedron. There are always 6 interrelationships of 4 points. So now I get to the minimum thought is tetrahedronal, and it has 4 stars and it has a minimum of 6 relationships. So we started with total universe and we found the simplest thinkable set. And it turns out to be a 4-ness with an inherent 6-ness of relationship. So as a 6-ness is a minimum number. When we use the word relativity or relationship, 6 is the minimum. You either have 6 or you don't have anything. And if we talk about stars or points, there must be 4 at minimum. Now I could have, a tetrahedron encloses the least volume with the most surface of all the geometrical figures. And a sphere encloses the most volume with the least surface. Tetrahedron, the least volume, the most surface. Sphere, the most volume, the least surface. They are the inclusive opposites. They are the maximum, minimum, conceptually, of inclusiveness. And they are the minimum kinds of sets. Where I would have the smallest amount of universe in the microcosm and the maximum amount of the same finite universe in the macrocosm. So between my tetrahedral kind of thinking and my spherical kind of thinking, I would have tendency to take total universe and divide it like an accordion. Sometimes pushing a lot of it in concentration here, sometimes expanding it outwardly. It is in itself a propagating, an oscillating, propagating act. Why? Because the very thought components, the stars which we consider, do something very extraordinary to the universe. Just as in Heisenberg's indeterminism, where the act of measuring, just the light brought to bear on the specimen, alters the specimen, gets it hotter, it expands, it moves. It is not the same as if it had not been measured. In the same way, a considered set of events in universe sets up some constellation here locally in universe. If we bring a fleet of boats into the mouth of a river from the sea and anchor that fleet of boats, we choke the river's mouth mildly. There's more friction of the river going by the boats. Get back. A few more words, and we don't need any shaping to get it. I would point out that my tetrahedron, because it consists of 4 vertexes, each of which have angles converging on it, are the most economic relationships of the edges. Each vertex has 3 times 60 degrees around it. And 4 vertexes, so that adds up to 720 degrees. A tetrahedron, some of its angles are 720 degrees, and that's quite independent of its size. This is something that has nothing to do with frequency. If I give you the size of the tetrahedrons, because I've made modular subdivisions of the edges of that tetrahedron in the terms of some other experience. I've got to give you some reference subdivisions. And size would be then something beyond. Tetrahedron is then something independent of size. I've given you we have conceptuality independent of size. Of synergetic strategies, very, very few. The first well-known one was when the Greeks said the sum of the angles of a triangle are 180 degrees, right independent of size and so forth. No special experience. But because they knew the whole, they could then, it is a corollary of synergy that the known behavior of the whole and the known behavior of some of the parts gives way a means of discovering what the behaviors of the other parts should be. The unknowns can be found. This is the trigonometry, based then on the sum of the angles of the triangle adding up to 180 degrees. That's the first great synergetic strategy of man. However, the next great strategy along those lines was a long time coming, Newton's gravity, where he said there is an attraction, a coherence throughout the universe, which we call gravity, which is in the terms of the second power of the relative proximities of the respective masses. Of the respective separate bodies. Then we come to, and in the terms of it, the astronomers said, all right, let's use gravity and calculate the behavior of the solar system. And when they did, they found the solar system was not explained by gravity, or else they needed two planets in the solar system that could not be found. So the known behavior of the whole as of gravity and the solar system being considered as a system, the known behavior of the whole, which was gravitational, said you need two more planets. So some men said Newton